To be honest, for a lot of what are we in, chapter 8? Yeah. Because as I mentioned briefly yesterday, what is chapter 8? Integration is net change, but what's coming next? Yeah. What's coming next is these guys. Ooh, hey look. What else is coming after? Areas, volumes by cross sections, volume, of solids of revolution with disks and washers, and then maybe trying to figure out what's going on with shells. Ooh, look at that picture. What are these? Getting three-dimensional volume using disks. I could take this apart and pull apart the disks using disks. Is that a perfect volume of this perfect shape? No, it's segmented. There's some error, right? Should be nice and smooth, but still, I could approximate. Are these disks? They're not slicing that way. They're not slicing perpendicular to the axis of revolution. Perpendicular. They're not slicing like disks. This one's slicing the three-dimensional solid parashell to the axis of revolution. And you're adding together cylindrical shells. Now, is this a perfect cylinder? No. Why? Because they wanted it to be pretty. Isn't this nice and smooth? Well, okay, it's not right this second. Sorry, I apologize. Isn't it nice and smooth? What did they do? They took away the error. So sadly, when we do this, are we going to be like, hey, let's make it nice and rounded? No, we can't do that. It's going to be awkward and segmented, but we're going to add together cylindrical shells, right? All the way through to get to your figure or your three-dimensional figure. And what do integrals do? Take these shells and make them infinitesimally thin, and as they go infinitesimally thin, then we'll get the exact volume. I already have water in there. All I need to do is plug it in. Do you want me to plug it in and the kids get it later?
That's fine.
Is that easier?
Is it hard to move when it's hot?
The handles will be fine as long as they don't like grasp it on the sides.
Okay.
Okay. I can send a kid over. Who wants to go take this for Senora to, thank you, Aryan, because then it'll be plugged in, it'll be easy to move.
Okay. Just set it on one of the tables on the senior patio.
Let me get you the plug. Aryan, hold on. Does that work? Hold on. Your poor finger.
Thank you.
There you go. Okay. But what else is chapter 8? You're going to be using your calculator for a lot of this, though, right, guys? Like you're setting up and then using your calculator to solve? Ooh. That's new. Gabriel's horn. Oh, and that's it. Okay. All right. So all that to say, kiddos, the things that I'm having you do in section 8.1, like using your calculator but getting the setup right, that's pretty much what chapter 8 test is going to be. Cool? Cool. So let's go ahead and grade. Nope, wrong one. Lo siento. Zoop, zoop. There we go. Number 12, final answer, negative 23 centimeters. If you got it wrong, check the setup. True? Because you shouldn't be making mistakes by hand because you're not doing it by hand for the most part. Deba. That's a good idea. Yeah. Ooh. Number 12, negative 23 centimeters. Number 14, you have 11 and 16 and negative 8. Did you guys figure out that was an at and not an over, and you had to add the initial plus the change? Good. Number 16, you're just looking at C. Steepest upward, that's awkward. Isn't that the same thing as the maximum positive slope? Or the point of inflection? Does that make sense? Kind of like logistic growth, super similar as far as the fastest, steepest upward. Anyway, 22, 26. 22 is 93.6 kilowatt hours. Okay. And number 26. Well, that's good. What happened? In radians? I feel like the function was a little different because we didn't do decimals, but we did something similar. Was it like a daily thing? We did the backboard one with cosine of pi over something. So it wasn't that one. And then we had the daily average consumption, but I didn't think, maybe it was that exact same thing. But Riley, sorry, long story short, when I check your homework spiral, I'm going to need to see something on it. Does that make sense? But you can just copy down quick. 26, 1,800 gallons. The amount of water that goes in is going to be an over. Sorry. I was just identifying this. This is over, the amount of water that goes in. But then the final answer is the amount of water at a particular time. So you have to take the over and you have to put that together with where it started, right? So where it started, how much it got added in, and how much got subtracted out. Was that an in-out problem? AP guys love it. Oh, is that it? Oh, that's no fun. All right, what do we got? Odds or evens? Hold on, let me write down. Number 9B, what else? 25, what else? 19A, what else? 22, what else? Is that it? Okay. Who wants what? Arya, 9B? Riley? Okay. 22. Who wants 19A?
Yeah, I don't even want it. No, that's what I asked.
Oh, that's me asking. I saw James first. Justin, keep an eye out. If you can find a mistake, you'll both get points. Yeah. Is that all it was?
Yeah, because it just said just find it wanted the over
Yeah.
from the hours past midnight. So it's just 0 to 24 of the function. And you get the right answer.
So why don't you do the setup, and then why don't you like write the integration as net change and be like, oh, hey, this is the over, and then this is the.
Okay, I'll do that.
You just use the wording. Does that make sense? Got that one? I think if you move the chair, there's space up there, Riley, next to Aryan. Okay. Okay, let me go mark theirs down, and as I do, you guys can start taking notes, and then we'll switch when I come. And you can be checking answers. Did you guys have any accumulation-y ones? Was one of those? Oh, yeah, Riley, you're right. We totally did do 22. But we didn't solve it. There you go. So you can get that done. So the examples in class were about as hard as the hardest ones of homework-ish? Okay, good. Let me double page it. That might be easier. Okay. You guys remember what this picture's from? Yeah, Khan Academy's, I think it's his intro lesson. Organization on there has gotten so much better in a few years as far as him having lessons per topic, intro, development, further examples, AP practice. He doesn't do a lot of AP practice in the midst of his lessons. but he does have it elsewhere. Whew. You guys finish your notes early and you're still waiting on people on the board, I am throwing in your next homework assignment in Google Classroom as we speak, so you could get that written down if you wanted. Let me see.
Just pass for this for the average daily consumption.
And I would do something to the effect of daily would be 0 to 24 hours. That should make sense, right?
Yeah.
And then yeah, the problem is we talked about this one in class.
Yeah, because I mean, I didn't do any work. Like, I actually
Average
solve it. Like, I
consumption
wasn't in my head.
rate of average. I know the average part's tricky if someone didn't catch it yesterday.
Yeah.
I think that works. Yeah.
Riley, was this your buddy?
Okay, so marking down points. 4. What grading period are we in? Period 3? Riley.
Maggie, took the integral of that?
Just in her calculator.
Why would I do that in my head?
Like cheat there. She said, correct the word, so.
Okay, well, that is correct word.
James, you had 1 too, right? Okay. Everybody's here except for Naomi. Maybe she's coming later because she's wiped out. So she might be trying just to hang in there for the play.
Does anyone remember the answer to number 6? It was like 21,180, something like that. I don't think so. Yeah, that was the final answer plus the 2,500.
Because it was 2,500 like plus 1,500 or something, and then minus the 2,000.
Yeah, it was 2,500 plus 1,800 minus 2,191.
Yeah. Do you guys have any questions about the ones? Well, maybe you should be able to see them, huh? Whoops.
Actually, no, it doesn't anymore. Yeah, we gotta do it. No, we just go.
Do you guys have any questions on the ones on the board? My ones that are looking at it? Which one?
I have the same integral, but when I plugged it in my calculator, I don't get that number.
Well,
I did it like a jillion times.
the t plus 2t to the 3 halves? 0 to 9?
I don't know why I'm like this.
Because the other one could have been like a degree radian problem, but this one should have been straightforward. What were you putting in? And you had the bound 0 to 9? Oh, sorry. Initial, but wasn't there an adding and something was going in and going out?
And then we can use our calculators. I was trying to.
Are we talking about 9B?
Yeah, 9B. I can't get that one. Is it 9B or 26?
She's talking about 26. I'm checking 9B.
Not with my calculator.
Wait, did you guys all get 344.52 after plugging into your calculator?
I'm probably wrong.
Did you get?
Yeah.
Did you get 234.9?
Yeah, I got 234.9. Really?
See?
And your integral was the exact same? What's the initial for 9B?
The initial is 0. It's at last.
Yeah. Well, what's in the textbook?
Absolute value? Wait, is it talking about total distance or is it talking about
It says how far does it travel in those 9 seconds?
Yeah.
how far does it travel?
So wouldn't that be just
I think it's going to be total distance traveled. I just don't like how they worded it. Because absolute value is going to add to it because then you're going to have some positive, some negative. It's just taking forever. Absolute value is the exact same thing? That doesn't make sense.
I'm recording. It's my calculator.
They give it to us in miles per hour.
Ooh, we had to convert. Booyah.
Wow, that was great.
But here's the struggle. That means that this doesn't work, right? But hold on, we got to fix it. So this would be 234.9. But what are the units, Issa? The ones given to you. And what do they need? Oh, wait. So this would be miles. And then what are they asking for? Wait, is it 9 seconds or 9 hours? Ooh, so what was wrong? The bounds. Because if your rate is in terms of miles per hour, does it make sense if your bounds are in seconds?
Because they gave us mph per second.
Oh.
Oh, yeah.
Oh.
Yeah, that's true.
Oh.
Miles per hour per second.
Yeah, it's really weird.
Yeah, what does that mean? Miles
Well, per second, it's kind of like acceleration, but not perfectly. Because it's not miles per hour, it's miles per hour per second, which makes more sense. Like your speedometer isn't changing per hour, it's changing per second or less. So it's how your speed, velocity, not absolute value, velocity is changing per second, yeah. Wait, what are they asking for?
What is the, how far does it travel in those 9 seconds?
Oh, that's even better. 234.9 is what you guys got? That'd be miles per hour, right? That's not answering how far did it travel.
You have to integrate.
No, think. You don't have to integrate.
total distance.
What?
Kind of. You need to build a bridge.
Oh, yeah. Oh, dimensional analysis.
That's what it's called. That's what I'm thinking. Chemistry, what's it called?
Yeah, just do some chemistry on it.
Because why wouldn't you integrate? No, I mean, it makes sense, miles per hour to go back to miles. Like, I understand the integrating. Why aren't we integrating? Again. Because of how they gave it to us. So the quantity is miles per hour, right? That could be like our box. And then we have d box dt. So our box is miles per hour. So we figured out miles. The problem is I don't have the context of the problem. Sorry, I'm just talking out of my butt. Hey, what number is this? 9.
Good, Riley?
Water? Have you guys even checked? If you can practically help? There you go. I feel that. Granola bars, almonds. It's a struggle.
Why?
talk to Dr. Sid right here.
Coke if it's logic.
Okay.
We're gonna get actually choking because it's the water. Just
Hey guys, this is the constant. This is the constant. This is the rate of. How can I say that? The automobile going at at, because you guys added the initial of 0 from rest, right? This is the speed that the automobile is going at 9 seconds. If you need to figure out how far it's gone during that time, I think I would have integrated again. Because I was thinking dimensional analysis at first, you could do miles over hours, and you could change it to be per second. Yeah, I mean dimensional analysis, but seconds. But I think if you were to do that, that'd be 234.9. You would have 600 seconds. That's not good. Right? Well, you get a fractional piece of a mile, so you could go feet. But I would go back one more. But to go back one more, pounds. This one was okay because of seconds. This one's not going to be okay because of seconds, is it? Although you have a constant. What happens when you do 234.9 times 5,280 divided by 3,600? Well, 234.9 times feet over miles, so times 5,280 to get to feet, and then divided by 3,600 to get to seconds, feet per second. 344.
452.
And you did 234.9 times? Yeah, see, it doesn't make sense, because you're saying that if we multiply this right now, you're saying that his speed was this the entire 9 seconds, but that doesn't make sense, right? He sped up from 0 to this during the 9 seconds.
Like it's the right number, it's just the decimal's the wrong place. Like if the decimal is just overdo it. The answer is 344.52. But we got 34,400.
But that was multiplying by 5,280 divided by 3,600. But hold on, in your minds though, it doesn't make sense that this is his constant speed if he's speeding up from 0 to this, right? So there has to still be an accumulation. So I think I would still do an integral, but to still do an integral, you can't just integrate that because that's not his constant speed. I would actually integrate again. Yeah.
I mean, I did it like that, like the dimensional analysis, and then so I would end up getting miles, and then I just transferred the miles to feet, and I got the right answer. I don't know why.
But that's what Aryan theoretically just did, and he said it ended up with like an extra 0. Is anybody else doing it?
So if I did the 234.9
Yeah.
divided by
3,600. Good.
I get 0.06525.
Well, there it is. Okay.
Oh my.
I said it a few times. I was like, right?
Fell off, bro. Fell off.
Wow, what a concept. Hey, Miss Steve.
With more alcohol.
Eat more again.
She just said, I need to wash down the oven with some more almonds.
Why do you say almonds?
Mrs. Regan. Almonds.
No one cares.
She says almonds, not almonds.
Where'd you even go? Oh, it's over there. It's almond.
Because there's people who say
Mrs. Regan says almond.
Almonds.
you don't have to eat a full
Let me eat almonds.
Diva, what was it? 4.5?
Yeah.
I didn't do my dimensional analysis. But did you guys see what I'm saying? I actually don't like the logic.
Yeah, I'm just gonna.
Oh! Nope, it still doesn't make sense.
Should we split it? It's on the floor. Oh, what is it?
When does she care?
How do you split an almond?
Yeah. No, gross. You want to split it? You split it open half on the floor. Oh, babies. You gotta split it.
Yeah.
Oh, I get it. It's like the Gophers.
Gophers, smokers.
It's accumulation. It's like the Gophers. It's like accumulation. Pause. Okay, it's silly that I'm thinking harder than you are. Question. Why was I thinking integration was necessary to go from miles per hour to miles? The initial 0 and it was speeding up, true? So if it was speeding up, isn't that typically an integration problem where integration is like, give me a formula for how it was speeding up and then I'll figure all that out and then I'll put it together with and get back to how the mileage changed. Dimensional analysis is when we were dealing with things like a constant rate and like, oh, distance equals rate times time. No big deal, constant rate. But was that the constant rate the whole time? No. But where did it come from? This wasn't the constant rate the whole time, but this also wasn't the fastest it was going. It wasn't speeding up until it got to 234.9. Going from 0 to 234.9, we're in some big trouble because there's no way that's the answer. Because you were going slower speeds, which means you were covering less distances. Does that make sense? Or smaller distances? This isn't the maximum speed. It isn't even to some degree. It could be as speed as possible. But we're integrating the miles per hour per second. You were accumulating all of the changes in miles per hour. Does that make sense? Like yesterday with the Gophers, we were accumulating all of the distance. You have a rate with respect to, like yesterday it was the Gophers per square mile per mile, right? It was the Gophers per square mile per mile. It was the exact same idea in the sense that it was a density and it was over time. The density was changing with respect to time. It's a super similar idea here in that we're accumulating to get to here. And it's not just like speed or, oh, that's what I have to. This is the accumulation of the speed that occurred between 9 seconds. And that's why we're able to take this and not say, oh yeah, it was going this speed the whole time. No, it wasn't. But this was the accumulation of all the different fluctuations of the velocity during that time and then using that as the number that we could go ahead and do dimensional analysis to. I feel like my explanation is a little bit lacking, but at least the idea is there. We can keep working on trying to perfect that. I need to figure out some sort of accumulation lesson to get a better conceptual understanding of what's going on because of the Gophers, because of this one with the miles per hour per second, and because of the one with the temperature and cooling down the house. Anyway, Maggie, number 26, you were still stuck on. Did you get it?
Yeah,
Go team. All right, cool kids. Area. What's the long story short? Top minus bottom or right minus left? Wait. When do we use what? Why is it top bottom? Why is it in terms of x? We have the dilemma over here of the problem. How do you find the area between the curves? And how does integration work? Doesn't integration accumulate rectangles and make them infinitesimally thin? Well, accumulate infinitesimally thin areas of rectangles. But how do we make the rectangles? The bases are the change in x, which becomes dx, and then the heights are the function values, which is why if you're doing top minus bottom, everything will be in terms of x. The delta x will be the base, the f of x will be the height. And so if we have a rectangle-oriented top minus bottom, that's when we're going to need x. Right minus left, what's the base going to be instead? Delta y, so we need a dy. We need our function in terms of y. So where does this get tricky? This one up here for A. Isn't this going to be an f of x minus g of x? Where f is the top one and g is the bottom one, and maybe it's exactly how they give it to you, and maybe it's different. What's our favorite that we can throw in just to make sure everything's okay? Yeah. Wait a minute, how do we solve integrals with absolute value? Like, what should we be looking at if we had by hand? Calculate, of course, we just put it in and we're done. But how do we think about absolute value by hand? Split at what? 0. These are the x-intercepts if it's just one function, but if it's a subtraction, can't we also say split at the intersections? Because the intersections are going to be when these two are the same, hence when the inside argument is 0. So we're splitting at the zeros, but the zeros are going to be the intersections of the two curves, which is why over here, the natural bounds are going to be when these two equal, which is going to be at 0 and 1. Could be given to you in the problem, might not be given to you in the problem. So intersections we're going to need to be thinking about. Orientation, as long as we're not just always using absolute value, is going to be helpful as well, keeping it positive. But left, right minus left. It's a little bit awkward, there are y bounds. But all that to say, since I have absolute values everywhere, oh, you need to go back, Maggie? Oh, got it. What's area between always supposed to be? Greater than 0. So think area between is thinking more the geometric area and less the application to displacement. Does that kind of make sense? Because integration is area, but how can area sometimes be negative? Well, the area is not, but in context, it could signify negative change, right? So then that's why with integrals, we have positives, we have negatives, above, below, positive change, negative change. But geometrically, area is area. It's always a positive. Length is always positive. As long as you figure out position vectors. Anyway, sorry. I'm going into way too many applications of when signs matter and when they don't.
What's that absolute value shortcut?
Absolute value shortcut are fail-safe and not really needing to worry about orientation. But we will still have to think about the intersections. Yeah. Because if you don't put in an absolute value, you better make sure that your top is your top and your bottom is your bottom, or your right is your right, your left is your left. Defined is going to be given. And naturally, you're going to have to find by hand. And if you're finding by hand, that's when you're looking at your intersections. But here's the struggle. Why am I going to put intersections under the given also? They could give you bounds where there's an intersection in between, and what happens if you don't account for that intersection? The top, what was the top and was the bottom is not always the top and not always the bottom necessarily, so then you could end up adding and subtracting without meaning to. And if you don't put an absolute value, you won't check for the intersections. So to be honest, the absolute value idea is probably safe to always at least consider. Are there intersections in between the bounds that I think are my bounds, whether given to me or whether what I've found by hand? And set up and solve. Justin?
If the top and bottom switch and you don't split like the integral up, then like, or nothing, if you don't flip them, what are you actually getting?
With your fundamental theorem of calculus, what you're solving for is, or what you're assigning to those shapes is, hey, this one where the top is the top and the bottom is the bottom as I defined it, I'm making that a positive area, and this will mathematically be a negative area, so you're taking away from each other, but not in a traditional sense of like, oh, all of this is positive change and all of this is negative change. You're saying geometrically that's a negative, that's a positive, so you're doing the wrong, ultimately, operation. So it's like an SAT math, you'd be subtracting instead of adding, which doesn't work. So what if, we might not do all the examples just because I don't think you guys need all the examples, Both of these are basic. Which one looks harder? Let's do that. Okay. Why are these called the basic, though, just in general? Not that you have to write them both down, not that we're going to solve both of them. Yeah, they give us our values. Why do I think the first one might be still a little bit tricky? And so when you go to set up, long story short, y-axis is x equals 0. About who's where. Could just go ahead and throw that in and throw in a dy and throw in a 0 and 2. No stress. See if there's any bounds, if there's not any, I should say, any intersections. But 3y only equals 0 at 0. You're okay. There's nothing in between. Pull out the absolute values. Just make sure you get a positive number at the end. If it's not positive, flip it and make it a positive. But down here, if I was to go throw this in, this has two functions. So if I was to, regardless of who's where, just put one in the first spot, put one in the second spot, put in an absolute value to say, oh, well, it'll make it right for me. What do I consider then? Yeah, I have to consider if the 0 and 1 is good the entire time or whether I need to split up because the orientation shifts. So how am I going to do that? Well, it's okay. Just see if there are any intersections. Off to the side, we're just going to check intersections. We have to check it for, if we're trying to figure out top bottom, check it if we have an absolute value. So either way, let's just make sure. It's a quadratic, right? X plus 1 quantity squared. Am I okay? Because it's not in between. So what can I do? I can pull out the absolute value and say, you know what? Even if I did orient this wrong, I'm just going to solve it the exact way as it's shown. And then if it's the wrong sign, just make it positive. But be careful. One of the most common mistakes, just, I don't know, it just happens, is when you're solving, to forget the absolute values are the very, very, very last step. You do your f of b minus your f of a. You have subtraction, just theorem of calculus. It's not you doing positive and negative area. It's you solving for the actual change, or I should say the actual area. So when you plug in and get 1/3 plus 2 plus 1/2, well, this one's awkward because it's just 0. But do the absolute values make sense? No. You do this operation first, just like PEMDAS has always told you. You go inside the grouping symbols, and once you go inside the grouping symbols, 2 and 3, 5, 6, is that what you get? If it's positive, stays the same. If it's negative, it flips. Don't go changing my fundamental theorem of calculus to be something it never was meant to be, or never should be. Absolute value just says, give me the final answer, do the f of b as f of a, and then check the sign. This one was positive, it stayed the same. No big deal. Think about as long as I what? Put one in the first, one in the last, and check for the intersections as to whether or not I should split up the bounds. Right.
So, since there's no intersections, why do you can you get an area still?
Well, because theoretically, if this one was on top of that one, which if you think quickly about, it's not. But if it was, sorry, there you go. I'd done it the wrong way, I would get a negative number. But I have messed up and taken some positive, some negative, and put them together and messed up my answer.
So if there is an intersection,
You have to split up. That one's still easy. But what's the point of this page? What wasn't given to you? So how do you find the bounds? Well, the zeros if you subtract the 2, or top minus the 0, or sections of them individually. The idea is the same. Okay, that makes sense. But guys, if you look at the picture, do you see how we would find our 2 intersection points? We would figure out that these intersect at 1 and at -2 by setting them equal to each other. So our bounds would be -2 to 1. And you could put him on top, put him on bottom. If you accidentally If you go for whatever, keep it the same. You just need the bounds to be what the math would show you. But some of you guys are asking for something tricky. How about this one? Oh, don't just do you don't know. What am I doing? Saying, I don't care, I don't want to think. There's one, there's the other. But what don't I have? So what am I going to do over here? So I just get 1. One's one bound. What's the other bound? Pull out an x minus 1 because they both have it, and this one's going to have an x minus 1 squared left over and then a minus 1. I have a 1, but I have more. Don't just go with what your brain sees. So they end up with what? X squared minus 2x plus 1 minus 1, right? Plus 1 minus 1. And that can... Uh-oh. You're welcome. But just add them. Because area between says find the area. There's multiple places where they... Okay, fine. Find all of them. So what are my bounds going to be? Huh? Does that make sense? So there's going to be a little pocket of area in one place, a little pocket of area in the other one. Why am I going to put big old absolute values outside both of them? Because I don't know who's top and who's bottom, and whoever's on top 1 second probably isn't the next second. Well, yeah, the next, whatever. Just be careful, because if you solve without considering them, without considering the intersections, or you do something wrong with your FTC, then they can. And remember how the multiple choice rarely uses, never uses values? It's an expression of values, which means you. That's mostly with discs and washers, because I like confusing you specifically with washers between the difference of pi big R squared minus pi little r squared, as opposed to pi times big R minus little r squared. They love to maximize on not everyone knowing the difference between whole. Never mind. We're not there yet. It's okay.
Wait, sorry. When are discs and washers used to when you actually have to find the volume of a function?
Well, solids of revolution is just a description of a type of figure. Does that make sense? So if you think of like an airplane hull or like a missile silo or of figures that could be described as a surface of revolution or a solid revolution. If you're ever needing to figure out how much space or what can fit or how much liquid it could take on, how much grain can fit in.
How'd you get a function for that?
Oh, you'd have to measure. You'd have to actually make a blueprint of it, and from that blueprint you could go ahead and find a mathematical model by taking set points. You know how we can make a function? We can make a cubic, we can make a trigonometric, just depends on the curvature. And then with computer programming you could make it fit. Like with Desmos or something, how you can manipulate functions. Yeah. And piecewise functions, you can do different parts. But anyway. Yeah. Huh? Think 3D printers. You have to give it parameters for it to know what to print. Has to be mathematically defined. 3D printers are so cool. Guys, why am I going to do this? The point is not to teach you how to integrate. Oh! Dun, 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 dun. 7 seconds left. All right, cool kid. Play with areas tonight. Are you allowed to use your calculator? Yes. What am I going to ask you for before you leave if you haven't given it to me already? Any more of these? Actually, hold on to these. We haven't gone over the answers. Do you guys know them all? 12 months in a year, 31 days in December, 1,000 years in a millennium, 1 leap year every 4 years. 4 seasons, spring, summer, autumn, winter. Anyway, I want your corrections by the end of the day. Sound good? Okay. And if you have your reflections, you can throw them in here too. I'll also grab some tomorrow. Yeah, chapter 6. Yeah, but I think I forgot to officially have you guys. Oh no, reflections were due. Reflections are what I'm supposed to be getting today. The reflections are what I was supposed to get today.